Alberto Arrigoni. I've been working for a couple of years at Pirelli in Carlos Group. And today I'm going to be talking about how we have integrated Domino and Plotly for smart manufacturing application development and deployment. So you may not know this, but Pirelli has over 20 different manufacturing sites all over the world. They're mainly located in Europe, but also China and South America and Mexico. So basically, it's a lot of data that is flowing to the headquarters here back in Milan that needs to be analyzed. And so we moved to smart. Carlo mentioned before smart manufacturing. So smart manufacturing is often connected to the Industry 4.0. I'm not sure if you're familiar with this definition, but we got this from Wikipedia, and it draws a parallel between the fourth industrial revolution and Industry 4.0. So basically, we're going from after the introduction of computer and automation into the factories. The factories themselves are becoming now cyber physical systems. So Carlo mentioned machine-to-machine communication and self-regulating factories. And so Industry 4.0 features a lot of different technologies, but we have been concentrating on big data and analytics, which constitutes a layer that sustains some of the other layers, probably all of them, and in particular, the industrial Internet of Things and security and the cloud itself. And so I may switch to Google Drive. That's just the resolution of I'm just going if we can see it, I then switch back to Google Drive. Cool. So as I was saying, this is a Pirelli vision for smart manufacturing. So it features three different sequential steps, and they're sequential in time and complexity. So we can start from the first, which is real-time analytics. We need to go from the acknowledgement of something that happened yesterday to something that is happening right now. This is the real-time, and we need for this advanced data mining to create data products. So basically, a data product is anything from a very simple, basic web application to something more complicated as predictive modeling, which is the second step. So predictive manufacturing is which is building and deploying models that can forecast product quality, for example, from process data. For this, we need predictive models and algorithms. This is the step Carlo was talking about. This is where we are at right now. And moreover, we have the third step, which is prescriptive manufacturing. So using machine-to-machine communication, this allows for process tuning and resource allocation, these three steps contribute to the vision of the virtual factory that Carlo was talking about before. So it's not only real-time analytics and data that we are seeing right now coming from the factories, but it's also about self-regulating factories, which allows, as I was saying, for process tuning and different resource allocations. So this is a very high-level overview of the architecture for smart manufacturing at Pirelli. And so we have data flowing from the factories, you see in the lower part of the slide. We have data ingestion step. So data is flowing back to our data lake and is stored in the Hadoop cluster we have in the headquarters. So as I was saying, we have data coming from the factories, but we also have a centralized infrastructure, a VPC that we use in the headquarters. And all this data is used, it's centralized, and we use it for training machine learning models to produce analytics, And once the data products are created and they can be deployed back to the local servers of the factories. We also have a smart alerting notification system, which we call ICAP, which is part of the second category of data products that I'm going to be showing later. I actually have a couple of examples of this. And so data products development follows two different and parallel lanes. So we have fast prototyping, which is, well, this is the tech stack that we use for fast prototyping of applications. We have Domino, Jupyter, and Blockly. And this, we use control user groups to provide a fast iteration loops where we can add features. We can add, we use these iteration loops to bring the products from concept to prototypes that we can directly deploy on our infrastructure. You can see on the right side of the slide. The technology that we use is slightly different. We also have, well, we use GitHub Enterprise for version control, Python, Blockly, and Domino, and then for front-end development, Angular, JS, although we're kind of switching to React. And so these are the two different parallel lanes for applications development that we use. And so we have to, we can detect we can split data products into different categories. The first category is for KPIs visualization and analytics. And this is like the simple kind. And in this, the data is human interpretable. We have small volume data. We have straightforward KPIs that we can identify. And this is basically descriptive analytics. We have a couple of examples of this, but still, so the bottom line is that the action is triggered directly from the visualization that we're going to get from the data that is flowing. And the second category of data products is smart alerting. In this case, data is no longer human interpretable because it's large volume, and we cannot identify straightforward KPIs. So we need machine learning algorithms and more advanced analytics. So basically, the action is no longer triggered by the simple visualization, but it's, the action itself is triggered from the algorithm perspective, from the machine learning algorithm. And so the visualization is still retained and is used to interpret the results that we're getting from the machine learning algorithms. And so this is like to put things in perspective. This is where data products are going when they're created. And this is very messy and noisy environment. And this is basically a 52-inch display that it's this is where when we deploy data products, and this is just to put things in perspective. I'm not sure which factory it is. It's probably a factory in Romania, but still, this is it. So I'm moving to the first example of data products. So you remember the two different categories. The first is just visualization, the triggers, the action. The second category is the machine learning algorithm that can produce, that can trigger the action, and that visualization is just used to interpret data. So this is the first kind. And so the goal, so as I was saying, machines in factories are organized in different production lines that contributes to different stages. And the process time for a single tire on the same machine for the same product should roughly be the same. So if we can find a discrepancy of the cycle time of a single product on a machine, we need to detect it. And this is a very simple application. So we analyze process time discrepancies on different machines, and we fit density distribution on cycle time data. As I was saying, so the goal is the detection of discrepancies between different distributions. And this is the visualization that we are using to detect this kind of discrepancies. So the analytical part is very simple. We are using a Kullback-Leibler a divergence metric in order to rank them. But apart from this, we are merely showing that there is a divergence, and the people from the factories need to go there and try to understand where this anomaly was generated. So the results are ordered according to the discrepancy that's been calculated between the distributions, and this application has been deployed on Domino. We created a custom launcher, and so it goes off every time. At each time of day, the workers in the factories are warned about an eventual anomaly. And so, as I was saying, machines in factories are organized in different production lines at different stages. And if this is the case, we need to have KPIs that are calculated for the tires that have been produced. These tires also need to be traceable. Now let's pretend for a second that we only calculate just one KPI for a single tire that's been produced. What we would like to know is a trend that we detect for that KPI and by a product category. We don't want to a KPI to go like out of control, and we need to know as soon as we detect that particular trend where it was originated from. And ideally, we would like to have it as early as possible in the production line. So let's try to see, this is also a very simple application. We just need to detect a one-dimensional trend in a time series basically. So this is an example of trend detection. An alert is sent every time a trend is detected, and this Python code that performs this operation is running a Domino. So it renders a report for decision supports, and the graph was produced using pandas, but we're going to see now. So this is a time series that we are dealing with. So for each KPI, we can identify trends using a sliding window on a relative basis. So we have different batches of 4 hours, and an analysis is run every hour. But at this time, when we were designing this pattern test, it was like one of the first tests that we produced for smart manufacturing applications in Pirelli. We were facing a difficult decision because R has a lot of great packages for time series analysis, and R is, well, it's great in general and for statistical analysis, and we were using that for a lot of things. And at the time, we were using also Python for infrastructural needs, and also there's SciPy, NumPy, Mathlete, Pandas is great for data wrangling. So we were, but it doesn't have a lot of support for time series analysis, and this is also true today. And so we were facing the choice. We had to re-implement everything from scratch, or we could have just used R. Fortunately, thanks to Domino, we could write, and this is very similar to what Nick was describing. We could write a code in R, and this code was deployed on Domino, which then in turn exposes an API that a client Python can access. So this is all for message passing and object conversion. I can also show you a very simple snippet. So this is all it takes to write a trend detection test in R. It's very simple. But this is also the code that it takes to run on Domino and to expose the API to the Python client. So this is the man-count test for monotonic training in a time series, and there's a package for that in R, as it often happens. And we run it on Domino, and Domino exposes the API that can be contacted by using a Python client. I was using here request. There's probably a custom Python client for Domino, but we could just use curl, for example. And so what we're passing here is as parameters JSON is a very simple time series. And the response is the trend p-value of that segment, of that batch that we are analyzing. And if we need to have something a little bit more complicated, we take a look at different parameters all at once. So remember, we were pretending we just had one single KPI for a tire, every tire that was produced. In reality, we have like dozens of different parameters and KPIs for every single tire that were produced. So we need to implement an anomaly detection system. So basically, anomaly detection is very relevant for smart manufacturing. Basically, we need to classify new data as similar or different to the training set. And we are using batch model training, which happens once a week, on some reference data, which constitutes the inliers data set. And we were using a machine learning model. It's also very simple. It's one class SVM with a regular basis function kernel among the different algorithms for anomaly detection that exists. And so we had a machine learning model that was working and was identifying anomalies, and then we had to display the same results for interpretation to the users. So we like to just not identify the anomaly in some process parameters, but we want to label the process overall as an outlier. So we're just showing the normalized reference distribution for process parameters on the training set. And then we can just show the, and it's not showing, but we have an inlier specified as such, and an outlier, and we can just pinpoint the single parameters that were detected. And this is a little bit of a digression, just one slide. But so the smart manufacturing team has been training a lot of people around the world. 130 people were trained in the factories, and they were trained from exploratory data analysis to the deployment of a web app using Angular JS. And the technology that was the key to this training was Domino that we use extensively, and also Python and Flutter. So basically, we would like to provide tools for data exploration to factory faults. And this was very effective. We got a lot of prototypes. So some of those prototypes were then later brought to production. And so this is the final slide. It's a bit of a summary of what we talk about here. And we have discovered that visualization plays a big role in factories as meant to convey key information to the workforce in the field. And so we have been using fast prototyping and fast iteration with control groups of users in the exploratory phase before bringing that to production. We are combining the output from algorithms and machine learning models into interactive web-based visualization to be used in production. This is for the future. We need to expand towards predictive and prescriptive manufacturing. So thank you very much.
So thank you very much, Nick. So we went very quickly through the two talks. We didn't. So this is the time for questions. So if you got any questions for Nick, Alberto, or Carlo, then don't be shy. Yes.
Hello, I had a question for Alberto, and I was interested to know how do you get the data from the shop floor? Because a factory is a living animal, so there is always something changing on, and you have to guarantee consistency of data at the time. So I would be interested to understand how you get the data to build the model. Thanks.
So the smart manufacturing team has a lot of different people involved. This is not only data scientists or data engineers. So the basic answer to that is the fact that we have a lot of different people from the factories that are using that are producing that kind of data. And of course, it's really hard to have reliable data. It requires a lot of insights, and we have a lot of engineers working on that, and we are actively collaborating with them. So basically, as you have seen in the high-level overview of the infrastructure, we have a lot of data that's flowing into a central into our central storage, which is also the data lake. We're exploring constantly different kind of solutions like S3 and different databases that are maintained by a lot of people. So it's online. It's a very difficult question, but to ensure reliability of the data. But we need to have people inside the data science core team that know what they're doing, and basically they're the same people who are working in the factory and try to ensure reliability of that data. I'm not sure if that answers, but
Because they are those people that are going to use the insights you provide.
Yeah, sure. That's so smart.
It's a cycle.
Yeah. So the one of the good aspects, or more or better, the aspects I like about smart manufacturing is that you can have fast validation of the algorithm that you're producing, and even validation for exploratory data analysis, like in real time. You can call it just the person and have the answer you're looking for.
Any other questions?
Question for Nick. Is Domino available for free, or maybe do you have plans to make some of the features available, or it's just for business?
Good question. Thanks. We have a cloud environment that we host and manage, and we make that available to students and hobbyists. But for commercial use, if you're sort of using it for your work purposes, then we charge for that. And you can do that in a version, an environment that we can host, or we can also run that in your own environment.
And in the environment available for students or hobbyists, is the API feature available or not?
It is, yeah.
Okay, thank you.
So just keep in mind that after this event, we'll send a follow-up email with all the references, links. So you will get access to all this, everything we will see now.
And we have also time during the visit or trains and bits.
Yeah. And also everyone will be here after the tour of the museum, so we can speak and make now. Now other questions? We've got a few extra minutes. Okay, so thank you very much. So now there's going to be a couple of guides from the museum. They will split into groups, and we'll go visiting, and then in around 40 minutes, 45 minutes, we'll be here. We will prepare the buffet for the aperitif.